Hello everyone, let's solve this Ferris wheel problem from CSES. So in this problem it is stated that there are n children who wants to go to a Ferris wheel and your task is to find a gondola for each child. Each gondola, each gondola has two properties, that is at max they can carry two children, and there is a weight limit on the gondola which is x here. So each gondola has a weight limit of x, we cannot exceed that, and we have to figure out how many minimum number of gondolas needed for the children. Okay, now let's look at the constraints. So looking at the constraints, one observation we should make is that this one, where weight of every children is always less than the weight limit that we have on the gondola. Now this basically means for every children we can assign individual gondola to them. Okay, now this will result in n gondolas. Okay, now the question basically demanding us to figure out whether we can do better than n gondolas. Now how can we do better than n gondolas is by using these properties of the gondolas, like whether we can pair the children. Now one way to solve this problem is by using two nested for loops and creating pairs of children and checking whether the weight sum of the children are exceeding the weight constraint on the gondola. So we can do via that approach, and if we go into that approach, so we will get a TLE because n is varying between 1 to 2 times 10 to the power 5, so it will result in a cute little TLE. So how can we do better, or how can we solve this optimally? Now one thing to notice is that obviously this property like pi is always less than equal to x. Now we can do better if we think in the direction how can we do the pairing optimally. Now let's take this example. We have been given 4, 10, 7, 2, 3, 9. Okay, now for pairing optimally what we need to do is, so we have to, let's short this 2, 3, 7 and 9. Okay, now let's look at the maximum element here, which is 9 here, right? Now for 9, which is the optimal partner for 9, so that we can pair it with like we can pair and have a minimum sum. Okay, that will be the minimum element in the list, which is 2 here. Okay, now if we sum this 2, then we will get the minimum sum with 9 as a member, right? Now why we are not pairing any other number like 3 and 7? Reason being, we have this weight constraint, right? Now to satisfy this weight constraint, for the maximum element we have to pair such a element which will result in minimum sum. So for example 9 here, if I take 9 plus 2, it will result me in 11, but if I pair with 9 with 3, it will result in 12, right? So if I increase this part, then the sum will also increase. Now in order to get the minimum sum, I only need to take the minimum one, right? Cool. Now if you look at it, so 9 plus 2, it is 11, but even with the minimum sum we are not able to satisfy the condition, because as x is 10 here, 11 is exceeding x. So we cannot pair 9 with any element, because with the minimum sum with 9 we are not satisfying the condition. So we have to assign an individual gondola to 9. Okay, now we will be left with 2, 3, 7. Okay, now let's look at the maximum element that we have. So this will be 7 now. Now let's check whether we can pair the max and the mean. So 7 plus 2, it will result in 9, And yeah, it is satisfying the condition. So 9, which is less than equal to 10 here. So they are satisfying the condition, which basically means we can pair these two children in one gondola. So let's put 2 and 2 here. Now after this, we will be left with 3, and 3 will be like minimum and maximum to itself. And with 3, we are not left with any other element so that we can pair with 3. So we have to assign an individual gondola to 3. So in total, we'll be needing 3 gondolas, and you can see like 3 is the answer. Now, the way to code is like using a 2-pointer approach, where one pointer will always point to the max element and another pointer will be pointing to the minimum element. So if we go via this approach, we can use these steps and we can optimally code it. And yeah, so let's directly jump to the coding part. So yeah, so we'll be taking n and x as the input. Okay, now we have to take the input for the weights of the children. Now all the elements are within integer bounds, so we don't need to take any long. So int will be sufficient. So w. Okay, now we have to do shorting, which is the necessary condition for all of our assumptions. Okay, now our assumption is like our right pointer will always point to the max element, left pointer will always point to the minimum element. So to work on that assumption, we have to short the elements. Cool. Now let's quickly write the 2-pointer approach. So L less than equal to R. Now why it is less than equal to R? So think when n is 1. Now when n is 1, we have to, so there is one child, right? And when we have one child, we have to assign an individual gondola to that child. So if I do L less than R, then L will be pointing to the first element, R will also be pointing to the first element, and this for loop will not run, and I have to like I will not be able to assign any gondola to that child. Now in order to run this for loop even with one child, so I have to put this less than equal to. Cool. Now let's do the sum of the weights of for the children. So this will be weights L plus weights R. Then I have to do if weight sum is less than equal to X, then I have to increment my answer. Let's initialize my answer. Okay, and I have to uh, move my minimum pointer to the right and my maximum pointer to the left. Otherwise, if the max element is not pairable with the minimum element, then I have to assign an individual gondola to the max element. So in that case, answer and R. Okay, now let's quickly print our answer. Cool. Let's remove this output. So I have already taken this input. Now let's run this. Cool, we got 3. Now in this code, you can see some redundant parts. So you can see like in the if condition, we are incrementing the answer and decrementing the R point, like the right pointer. And in the else condition, we are doing the same thing. So we can do something like this. This will also work. Reason being, as the question constraint, like pi is always less than x, which basically means I always have to assign a gondola to one of the child, right? Now, so in the max element, when I have to simply check whether I can pair the minimum element to it, which is this condition. And if I'm not able to pair this, like if the if condition is not satisfying, then I have to assign an individual gondola to the max child. And then I have to increment the answer. But if the if condition satisfies, then again I have to move the right pointer and increment my answer. So that's why this was redundant when we are using if else statement. So we can simply put it here without any condition. So yeah, let's submit this code. CP. Cool, all got accepted. Now let's quickly do a time complexity analysis. Now, if you look at the complexity, so the time complexity of this loop is linear, and it will be like the number of elements that we have, because in a list my left pointer is moving on the right and my right pointer is moving on the left. So there are no nested iterations I'm doing. It's like I'm traversing the same array in both the direction. So at max I will be doing n steps, so big O of n. Okay, but big O of n is not the actual time complexity because we have this shorting here. Now we know well, like the time complexity of a shorting is n log n. So it will be n log n plus big O of n. So the worst time complexity will be big O of n log n. Now let's quickly do the space complexity. Now here we are only dealing with variables, and weights are just like inputs. So we are not using any auxiliary space complexity, like any extra space we are not using. So whatever input we are getting, we are running the shorting. So it is big O of 1. So yeah, these are the time and space complexity. So I hope you understood like the approach to the problem, and I hope you learned something new. So yeah, just stay tuned to watch more videos. Thanks.